Let's summarize all of our absolute value transformations. We can do this with this top function rule that includes all of our possible transformations. F of x equals a times the absolute value of x minus h plus k. First, what is the effect of a? What transformation occurs to the parent function if we multiply by a coefficient a in front of the absolute value bars? Well, we will either vertically stretch or vertically compress our graph. If a is big, we will vertically stretch it, meaning make it steeper. If a is small, we will make the graph flatter, meaning we will vertically compress it. If that a value is negative, if we have a negative in front of the absolute value bars, that causes a reflection over the x-axis, meaning we have a v that faces down. Inside the absolute value bars, we are subtracting h. H indicates a horizontal shift, left or right, in the opposite direction you would think, because we're subtracting h. If we end up with subtracting a value, that means we're moving to the right. If we have an addition, that means we're moving to the left. Finally, this parameter k outside of the absolute value bars shifts the graph up or down. It represents a horizontal movement. And this is just in the direction you would think. If we're adding, we move up. If we're subtracting, we move down. That means we can identify the transformations from each of the function rules below. A of x has two transformations. A of x equals 3 times the absolute value of x plus 6. First transformation is this 3. That's the a value outside of the absolute value bars and is either a stretch or a compress. Which one is it? A greater than 1 is a vertical, I'm going to write vert stretch. You are also allowed to write that it makes it steeper, but vertical stretch is what you'll be saying in Algebra 2. Plus 6 moves the graph horizontally, the opposite of what you would think. You think it moves it right, it moves it left. So we're shifting left 6. Next function rule, b of x. Let's do c of x first, actually. C of x equals 1/3 absolute value of x minus 6. Two transformations. First, this coefficient of 1/3. This is again a stretch or a compress vertically, but it's a small a, an a between 0 and 1. That means this is a vertical compress, which you're allowed to say makes the graph flatter. So a fraction makes the graph flatter. Minus 6 is a k value outside of the absolute value bars. Subtracting means we're moving down 6. On to b of x. b of x equals negative 3 absolute value of x plus 6. Now that I have this negative sign, I have a reflection over the x-axis. Reflect over x-axis. You can also write the v opens down or that the graph is upside down. Reflects over the x-axis is the Algebra 2 sophisticated way of saying it. The 3 is still a vertical stretch, meaning it makes the graph steeper. The plus 6 outside of the absolute value bars shifts the graph up 6. The k moves the direction you think. The h is what moves you the opposite. Last function. Negative means we've reflected over the x-axis. The v is upside down. It faces down. It opens down. The 1/3 is a little a. That means it's a vertical compress. You can also just say flatter. And then inside the absolute value bars. Inside the absolute value bars, we're moving left or right. It's the opposite of what you would think because we're subtracting h. So you think, hey, I'm moving left. Nope, right, 6. Now we can use this identification in order to label our graphs. So which of these 4 graphs has a vertical stretch and is moved left 6? Yep, this is a of x. Vertical stretch, it's steep, and it's moved left 6. Next up, c of x. We're looking for a vertical compress and down 6. So we're looking for a graph that is flatter and shifted down. Here it is. This is c of x. Now we're looking for b of x. b of x is reflected over the x-axis, meaning the v opens down. It's vertically stretched, meaning steeper, and it's shifted up 6 as compared to the parent function. So these are not compared to each other. They're all compared to the graph of the parent function, f of x equals the absolute value of x. Okay, so reflected over the x-axis, vertical stretch up 6, that would be this guy. This is b of x. Finally, I sure hope this is d of x, is it? Reflected over the x-axis, check. Vertical compressed meaning flatter, check. And right 6, hooray. If we weren't given these bullet points and we were just asked to match function rules to graphs, we would do this in our head. We would think, oh, these are the transformations, and then I would find the graphs that exhibited those transformations. Last example, g of x equals -8, absolute value of x plus 1 minus 4. 4 transformations to identify. The negative means we are reflecting over the x-axis. I hope that you're listening to my words because that is illegible. Reflect over x-axis. The 8 is a big A. That's a vertical stretch. You can also just write steeper. You can't write skinny. Skinny is not allowed. The plus 1 inside, so inside the absolute value bars is left or right. It's horizontal. Because we subtract h, it's the opposite of what we would think. We think it's moving right. Nope, left 1. And finally, outside the absolute value bars is up or down, exactly what you would expect. This one is down 4.